Hi everyone. So today we are going to discuss about insulated gate bipolar transistor, which is an IGBT. IGBT has been developed by combining into the best qualities of the BJT and the power MOSFET. So IGBT possesses high input impedance like a P MOSFET and has a low on-state power losses like a BJT, and it is also free from a second breakdown, and it is also called as MOSIGT, COMFET, gain modulated field effect transistor, and IGT, integrated gate transistor. So and next, coming to the circuit symbol of the IGBT, so it is going to be like this, so which is going to be having the three terminals like gate, collector and emitter. So now coming to the basic structure of the IGBT. So this was the structure of the IGBT, which consists of a layered structure of the IGBT, which consists of the gate terminal, emitter terminal as well as a collector terminal. Here, same as in the case of the P MOSFET, here also we are going to have a SiO2 layer which was connected to a emitter terminal like this. So now coming to the fabrication structure of the IGBT, so it is going to be having the base as an P plus substrate, which is going to be called as an injection layer. So and the collector is going to be connected to that P plus substrate, and this P plus substrate will inject holes into the N minus layer, so which is going to be called as an injection layer. And next, and to this P plus substrate we are going to grow a drift region, which is an N minus region, which is going to be called as an drift region. And here onto this we are going to have a P moderately doped P region, which is going to be called as an body region. And onto this we are going to diffuse the N plus layer like this. So the N plus layer is going to be diffused into the body region, and the emitter terminals are going to be connected to this N plus substrate. Heavily doped N region is going to be connected to the emitter terminals with SiO2 layer as shown. So SiO2 layer is connected in between the emitter and the N plus substrates, substrate. And next, coming to the P body region, N minus drift region. So for the N minus drift region, so we are going to have a gate terminal connection like this, gate to the emitter terminal connection like this. So right, so and here we are going to, for explaining the working operation, we are going to consider the emitter and the collector is going to be connected with an emitter collector voltage VCE as shown, and gate and the emitter is going to be connected as like this with the polarity. The gate with respect to emitter was positive, and here collector with respect to emitter was positive. We are going to consider like this. So same as in the case of the P MOSFET, here also the channel was created such that to have a flooding of the electrons into the N minus drift region, due to which we are going to have a conduction from N plus region to the N minus region. So here we are going to have three junctions, say between this P plus and N minus, which is J1, and N minus P, which is J2, and N plus and P, which is J3. So now coming to this, so same as in this case, generally we are going to represent. So we are going to connect, see here, when collector is made positive with respect to the emitter, IGBT get forward biased. And when we are going to make the device forward bias was when the collector is made. So as in this connection how we have represented, when collector is made positive with respect to the emitter, this is said to be in the forward bias condition. So as we know that when this was in the forward bias condition, so what happens, so the junction what happens to the junctions J1 and J2? So J2 junction is going to be in the reverse bias condition. So due to this, indirectly the P region and the N minus, this J2 junction was going to be reverse biased. J2 junction is going to be reverse bias. So due to this reverse bias junction, we don't have an current flow right away from N plus region to the P region, that is emitter to the collector. We don't have any sort of current flow. So now due to this, so we are going to make the gate to the emitter voltage, gate terminal with respect to positive VGE, the gate voltage was going to be supplied such that, so due to the presence of the silicon dioxide layer here, which acts as a capacitive element, so in this region what happens was the positive charge, so when we supply the gate, so positive charge is going to be gets accumulated at this region. So and then, so due to the behavior of this, so in the P region, so in the body region, what happens was, so the negative charge was going to be accumulated like this. So as we are keep on supplying the gate voltage, so the positive charges which are going to be accumulated in the SiO2 layer, so and in the P body region, so the negative charges are going to be gets accumulated. So and when this going to be happened, then there is a chance of conduction right away from, so this between this P junction and N minus junction, so we are going to have this N plus can now inject electrons into the N minus region. So by making this N channel, so this channel, this creates a channel now. So this is an inversion layer now. This is an inversion layer. So due to this inversion layer now, so this N plus region can inject electrons into the N minus region, and as well as, so this when this gets forward biased, so the holes which are present at this J2 junction are going to be flooded into the N minus region, which are going to be gets recombined. When the holes and electrons are going to be gets recombined, then the conduction is going to be happen from N plus region to the N minus region. So ఇక్కడ ఏం జరుగుతుంది with this, ఈ SiO2 లేయర్ ఇక్కడ ఉండడం వల్ల we are going to have the capacitive behavior of this SiO2 layer. Capacitive behavior ఉండడం వల్ల ఇక్కడ we are going to have a formation of the positive charges, accumulation of the positive charges at this end, and అదే విధంగా మనం పవర్ మాస్ఫెట్లో ఎలా చదివామో అలాగే ఇక్కడ P బాడీ రీజియన్లో N మైనస్ దట్ మీన్స్ నెగిటివ్ ఛార్జెస్తో ఒక ఇన్వర్షన్ ఛానల్ అన్నది క్రియేట్ అవుతుంది. సో ఆ ఇన్వర్షన్ ఛానల్ క్రియేట్ అవ్వడం వల్ల ఈ ఎన్ ప్లస్ రీజియన్లోని ఎక్సెస్ ఎలక్ట్రాన్స్కి దెర్ ఈజ్ ఏ when we keep on increasing, because this VC is in forward bias condition, సో మనకి ఇక్కడ ఎలక్ట్రాన్స్ ఎక్కువ అవ్వడం వల్ల సో ఈ J2 జంక్షన్ అన్నది స్లోగా ఇట్ ఈస్ గోయింగ్ టు బి కన్వర్టెడ్ ఇంటూ ఏ forward bias junction. Then what happens, slowగా ఇక్కడున్న electrons they are going to be injected into the N minus region, and ఇక్కడ P plus regionలో బాడీ regionలో ఉన్న ఎక్సెస్ హోల్స్ అన్నీ they are going to get starts recombining. సో recombining జరిగింది అంటే that means that ఇక్కడ depletion layer is going to be faded out and we are going to have a continuous conduction. So continuous conduction వల్ల we are going to have a voltage which was current which was going to be flow from emitter to the collector, right? So this was the fabrication operation of a IGBT element, right? Thank you.